All right, so I'd like to, now that we have this Bob user, let's start to tinker around as Bob, specifically in the sandbox users directories. All right, so apparently I'm logged in as Bob, and I can go to Sandbox's desktop, right? If I do an ls right here as Bob, it's like I can still see that James folder and that Rice folder that I had created before. And if you remember before, I had created some files inside that James folder. So if I do an ls of James, it's like, hey, yeah, there's some example 1, example 2, example 3. So I'm logged in as Bob, and I can see the sandbox user's stuff. Is that a good thing? Is that a bad thing? It's like, well, apparently some information right now is being shared. All right, and so I'm not going to emphasize whether this is good or bad. I'm simply going to emphasize, do you realize who has access to what? It's going to be really critical to understand some of these permissions. Well, let's take this a step further and say, okay, there was some information in those example files, right? Sandbox user wrote some information in those files. Can Bob actually see it? Can Bob actually read the contents of the file itself? Well, let's give it a try, right? We have the cat command. I could try catting out /home/sandbox/desktop, and then we had the /James/ let's try like the example1 file, something like that. And it's like, yeah, there's a bunch of stuff there, right? Hello world, all my messages, more data, blah, blah, blah. It's like, yeah, so it looks like Bob was actually even able to read the contents of a folder and see the contents of the file inside of it. Okay, so if you're really serious about saying, hey, I've got some things that need to be private, you definitely should understand from the start, if you just make blank files and start writing stuff inside them, it's probably the case that other users on the computer will also be able to see it. Now, I guess here comes the million-dollar question. Can Bob make changes to the file that was owned by the sandbox user, that the sandbox user created? Well, let's give it a try. We had learned last time that there were things like the nano command or VI. I don't really care which one you try out. We're going to try both of them here. So it's like if I try nanoing into that example1 file, let's see what happens. If I nano into /home/sandbox/desktop/James/example1, let's see what happens. All right. So it looks like I can open the file and I can look at the data, but notice in red, you've opened a file that is unwritable. All right, so Nano is trying to tell you that you do have access to the file, and it might look like you can make changes, right? It kind of gives the impression, oh, look, I can type. But what you're not going to be able to do is you're not going to be able to save those changes to this file. So if we try doing that, Control-X-Y, enter, right? Control-X-Y, enter, it's going to say, permission denied. You don't actually have writing permissions to this file. So as the Bob user right now, this particular file that belonged to the sandbox user, this is a read-only file. It's not something you'll be able to write to. And so even though it looks like you're writing, you'll never actually be able to save the changes to this file. And so in other words, what we'll have to do is press something like Control-X and then say no to discard my changes. And so, yeah, if I cat the file out again, it's telling me, yeah, this is read-only. Cat allows you to read it, but I can't actually go in and make changes. I wouldn't be able to come in and overwrite this file and change all the data in it. At least not as the Bob user, not yet. Let's see if we can understand a little bit more as to what's actually happening with the permissions and see if we can wrap our head around how do I tell the difference, is this a file that I actually have permission to or not? Let's see how Linux will explain some of that information to us. Now, when you run the ls command, it will show you the contents of a directory. So if I run ls of the desktop, it shows you right here, these are the things that are inside the desktop. If I run an ls of James, like that will show me the contents of the James folder. However, there is an additional option that would allow you to see not just the contents, but also allow you to see some of the permission information as well. And so that additional option is the -L option, a very useful option to know when you run the ls command. So if we wanted to check what are the permissions on those files inside the James folder, instead of just doing an ls of James, let's do an ls space and then add on the -L option. We'll have some additional functionality. And the additional -L option will show us, as we see here, it's like, well, now it doesn't just list the files. Here they are, example 1, example 2, example 4, etc. But notice it also lists a whole bunch of other stuff as well. It's like, what the heck is all the rest of this other stuff? All right, and we can see this as well if we do it in our current directory, right? I'm here in my at the /home/sandbox/desktop. If I just do an ls-l right here on this current one, it's like we can do the same thing for folders as well. All right, so don't think that this is unique to just files. It'll show you folder information as well. So here it says the James folder and the Rice folder, and it's like, okay, there's a whole bunch of other stuff here going on. What the heck is all this? It's like, well, let's jump over to some slides here for a second and try to understand this. So Linux will present information to you when you run the ls-l command to try to show what are the read permissions, the write permissions, the execute permissions for a particular file. And it takes this information and it breaks it up into different categories. So let's take a look at one of these examples here. So that's what I'm emphasizing. You've got read permissions, write permissions, and execute permissions. That's the R, W, and the X. Okay? And you'll also notice that Linux will try to differentiate between, is this item a file or is this item a directory? So let's look at the structure here in these examples. So you can see in this first example, I'm indicating this is an example of what a directory would look like. It would start with a lowercase d for a directory. The next bit of information you're going to have will relate to whoever owns the file. What are the permissions for themselves on that file? So they'll have a read, a write, and an execute in that order, RWX. So in this particular case, I'm showing an example of a directory where whoever owns the directory, that owner of the directory, has read permissions, they have write permissions, and they have execute permissions to that directory. Okay? You'll then have another set of RWX. And the second RWX refers to, well, what about the group that belongs to, that file belongs to, or in this case, that directory belongs to. And again, we'll get into group information a little bit more after we've covered just basic user accounts. But nevertheless, the group will also show us an RWX. So in this particular example, it's telling us if you belong to the group, you have read permissions, but you don't have write permissions. But you do finally have execute permissions. So that's what the little dash oftentimes means, is it means you don't actually have that permission. All right. And then finally, you have everyone else, the everyone else category on the computer. So there's the owner, there's the do you belong to the same user account group, and then finally everyone else. So this one's showing an example where everyone else, if you are not the owner and you do not belong to the group, then you will have R just dash and then X. So in other words, you don't have write permissions to this particular directory. That's what this sequence of characters is trying to represent. So this is a really important sequence of characters to be able to read. You want to be able to read these characters and understand what they mean from a permissions perspective. Here's another example. Right, another example in this particular case is, well, this is what a file would look like. It wouldn't start with a D, it would start with a dash. And then again, you'd have the RWX, even for the owner. So what this indicates is the owner itself, the person who owns the file, cannot actually execute this file. It's just read and write, but they can't execute. And that would be common for just basic files that are not actually programs. Right? If the file itself is a program, like an executable style program, then yes, it would need the execute permission. All right, but for your average file that's just keeping track of text, many of those files don't actually have the execute permission, even for the owner. The owner can restrict their own permissions to say, no, I can't try to run this like a program because that's not what it is. All right, but nevertheless, you'd have this read writes, and then you can see here for the group, maybe the group also has read write, and then everyone else just has the R. Right, you would have the R with no write permissions and no execute permissions for everyone else. So let's take some of these examples and reference back to our Ubuntu machine and see what are we looking at here inside our machine when we run our ls-l. So let's take that information, take a look at this. So I've got my example1 file. Here's the example1 file. All right, and if we look all the way over to the side, what it's telling us is like, yep, it starts with a dash. That means it's a file. It's not a directory. And we can see here, it's like, well, the owner of the file has read, write, but not execute, which again makes sense. It's a blank, it's a file that has some basic text information, and it's not something that's a program. If you belong to the same group, you also have the same permissions. So if you're the owner or if you're in the group, you also have read and write permissions, but no execute. Everyone else, what does everyone else have? Well, everyone else has read only. That's the basic permissions that come when you create a file, either using the touch command or the echo command, or we use nano or vi to go and create a blank file. Like, that's the basic permissions that oftentimes come with your different Linux distributions. You have read write, and then finally just read only for everyone else. You'll also notice here how it says sandbox twice, right? It says sandbox and then sandbox, sandbox and then sandbox. And this piece of information is showing you as well who is the owner and who is the group that this file actually belongs to. So when you're unsure, well, okay, apparently the owner has read and write. Well, who is the owner? Well, it tells you right here. It tells you right here that actually the owner of this particular file is the sandbox user. All right, and the group that this belongs to is also the sandbox user. So who is Bob? Right? When you think about it in the big picture, Bob is a brand new user. Bob is not sandbox, and Bob does not belong to the sandbox group because we haven't added him to the sandbox group. So don't worry, we'll get to that in a little bit later. But nevertheless, it's like, okay, great, I've got this Bob user, and Bob would fall into the everyone else category. Right? Bob falls into this everyone else category, and that's why Bob can read the file, but Bob cannot actually make changes to the file. So he looks like he can open it up with nano or could open it up with vi, but he won't actually be able to save any of the changes when he tries to do that. Okay, you look down at the directories, right? Look down at the James directory and the Rice directory. Looks pretty similar, right? You got the D for directory, and apparently it's got RWX, but likewise just the R-X. So for everyone else that's telling us, it's like, well, you got read permissions to this folder, you can see what's inside the folder, but you can't actually write to the folder. Okay, so again, just being able to read the permissions is a really critical thing, and ls-l is an excellent command to be able to show you the permissions and actually break down what are the permissions for the different files and folders, which is absolutely critical from a security perspective. Do I want Bob to be able to read this file or not? All right, that's definitely something that's critical. So what happens if you're Bob right now and you try creating your own file inside the James folder? Let's give it a try. So we saw last time we could use the touch command, right? Touch is a way we could make a file. And how about I'll just call it like Bob's file? Yeah, sure, something like that. But I'm going to touch the file inside the James folder. So let's try doing that. I'll try adding it inside James/Bob's file. Yeah, sure. We'll try creating the file inside that James folder. And what happens? It's like, well, cannot touch the file. Permission denied. Why? Which one of these permissions stops us from writing to this folder? It's like, well, here's the folder. Here's the permissions. Bob is not sandbox. Bob does not belong to the sandbox group. Bob falls in the everyone else category. So Bob can see what's inside the folder, but Bob cannot create his own stuff inside that folder. All right. So that's currently where we're at with these different permissions. Okay. Well, all right. Let's take this a step further. Let's give Bob some permissions. All right. Let's see how we can give Bob some permissions. And I'm going to go about doing this by saying, all right, let's leave Bob in this terminal over to the side, and let's open another terminal. All right, so if I right-click on the desktop and say Open in Terminal, or you go down to your little Applications window and kind of get one started up that way, however you want to start it up, I'm going to kind of have two terminals side by side, and kind of the big thing I'm looking at here is if I do a who am I, like, well, this new terminal, this one's running as the sandbox user, whereas the one on the left, well, this is my Bob user. All right. And so the general idea of what I'd like to understand here is, okay, we could use ls-l to see what the permissions are. Well, what if I want to change the permissions? All right. That becomes just as critical to know, is not just what are the permissions, but how do I go about changing the permissions? How do I restrict access? How do I give a little bit more access? Yeah, definitely something we want to be able to understand. So let's jump back over to the slide here real quick and understand that there is a command to be able to modify these RWX, RWX, RWX. You kind of have three categories of people: the owner, the group, and everyone else. And the nice command to be able to do this wants you to type in the value that represents the permissions for each group of people. So you have to come up with a value that says, what's the value of permissions you want to give to the owner? What's the value of permissions you want to give to the group, and what's the value of permissions you want to give to everyone else? And the way that Linux handles this, or at least one way to understand, the way I'd like to show, is that it does a little math equation. It actually does a little math equation. So that's what I've added in here in the middle, is so that you can see what is the value that's associated with read permissions. What's the value associated with write permissions? What's the value associated with execute? And then finally, what if you just had no permissions? What's none? All right, and so they have these different permission values of 4, 2, and 1. And so the whole idea here is you're going to use a command and list out the number that represents what are all the permissions that you want to add. So let's take a look at first, how about we start with our example 2, because this is kind of what we're dealing with, right? We've got some directories, we've got some files, so let's take a look at both of these and see what would the math equation for this kind of add up to be. So if we start here with the file, what the file is saying is that you've got read permissions, write permissions, and then no execute permissions for the owner. So if you add all that up, that RW and then a dash, RW and then no execute, that would be the same as, well, read is 4, write is 2, I don't have execute, and obviously I don't have none, so you'd say 4 plus 2 is 6. So 6 is how I would represent the value of read, write, no execute. All right, so if I look at this permission overall, it's like, well, I've got a 6 that would represent the owner. For the group, it would also be a 6. It's also a read plus a write with no execute. And then everyone else, well, it's just a 4. Right? I don't have a 2 for write, I don't have a 1 for execute. So I could identify this to the computer by saying the permissions are the same as 664. 664. That would be an example of how this example on the right is actually represented. The example on the left would be something a little bit different, right? Because this one has read, write, and execute. So if you've got read, write, and execute, that would be 4 plus 2 plus 1. So you'd have a 7. The owner permission is represented by a 7. The group has read, no write, but an execute. So it's read is 4, no write, that would be a 0. Execute would be a 1. All right, so that would be a 5. And then obviously everyone else has the same thing. So this permission would be represented as 755. 755. And on the right, we had a 664. So understanding these little math equations and seeing what these numbers are is critical to being able to put permissions into practice. And it just takes a couple examples to be able to do this. So let's see if we can modify them. Okay. So as the sandbox user, right? I'm here on the right. I'm as the sandbox user. They're the ones who currently own the folder. If I wanted to give permissions to this James folder so that the Bob user would be able to write to it, I'd have to give, the real thing that's critical here is that last RWX. That's the one that's really missing. You can see the first one, it's like, well, it's already RWX. That's a 7. The next one is also RWX. That's another 7. And then finally it's R-X. So that one's just a 5. That's the 4 plus the 1. All right. And the command to be able to change this is a chmod command. Chmod. Okay. So this particular command wants you to put what are the numbers that represent the permissions of the thing that you're trying to change. So if I wanted to change the permissions on that folder, I could say chmod. I want to keep my own permissions the same. I'll keep it as a 7. I'll keep the group permissions the same. I'll also keep that as a 7. But I'd like to change this last permission. The last permission right now, it's just a 5. It's just the read plus the execute. Okay, and what of course I need to do is I need to add in the write. So I need to add it into 7. So yeah, this is a common permission you might do, which is give everyone access to everything, right? chmod 777. And now what am I running this on? Well, I'm running this on the James folder. All right, so I could say chmod 777 of James, and because I'm the owner, it will allow me to run this command. It's like, yes, you have the authority to change permissions to the stuff that you own. All right, so now we'll do an ls-l, take a look at it. It's like, there it is. You can see here that running that command changed this last group. It changed this last group from a 5 to a 7, and now I have the actual write permission. And you notice Linux, or at least Ubuntu, will do this. Ubuntu oftentimes highlights things in green when the permissions are 777. When everyone has full permissions, it kind of tells you, hey, this is something that everyone has full permissions to. Not public at all when it comes to access. So, okay, so if we do this now can Bob touch his own file inside the James folder? We'll try touch James inside the James. We'll do Bob's file, and we'll see this time the command did not give us a permission denied, right? If I try an ls of James, it's like, well, I got those example files, and I also have Bob's file. Bob's file is also in here now. Okay, cool. Well, now that we've got a couple different files inside of this, let's actually take a look as Bob here. Let's actually look at the permissions of it as well, right? So we'll do an ls-l of James. James, take a look at all the permissions in there, and we can now clearly see this is what it will look like when you have different users. Right? The sandbox user owns the example files, but the Bob user owns the Bob file. So yeah, it's possible that even though the James folder belongs to the sandbox user, well, that doesn't mean that everything inside that belongs to the James or to the sandbox user, right? So in this particular case, we actually have files that are owned by a different user inside someone else's folder. Yeah, if the permissions are set up that way, it'll allow you to do that. Maybe we'll also try modifying the permissions on that example file, right? Bob was trying to make a change to this example1 file, and unfortunately, Bob only had read access, right? He didn't actually have write access. So let's try changing that as well. As the sandbox user, I could try saying, well, we'll do chmod, and now I want to say, okay, what are the permissions right now? The permissions right now are read plus write, that's 4 plus 2, so that'd be a 6. Another 4 plus 2, so that'd be a 6. And then finally, we got to read and nothing else. All right, so 664 is what many of the permissions on files will start with. And if you want to give other users access to be able to read this, then yeah, you kind of got to go and change the permissions chmod 666 to be able to make it that's read write, read write, read write. We don't really need the execute permission. And now you have to say what are the permissions that you're trying to change to what file. All right, and so you can give the full file path, right? We could say something like /home, /sandbox, /desktop, /James, finally example1. Like, yeah, sure, that would work. Well, you could do the relative reference, you could do the absolute reference, doesn't matter, but either way, we got to be able to change the permissions to this thing. So now when I do that ls-l command again, right, we'll be able to see, that's the change we just made. We just tacked on that extra write permission for everyone else. So now if Bob tries opening the example1 file and making a change to it, let's try doing that with vi. All right, this time we'll use the vi command, so I'll say vi of James /example1. If I try going into this file, it's like, oh, it doesn't give me any read-only, messages or errors here at the bottom. And if I hit I and go to insert mode, maybe I'll go like to the very bottom of this file and like add on another line like Bob was here. Whatever, just adding some stuff in. It's like, yeah, sure, Bob should be able to make changes to this file. I could hit escape to leave insert mode. I'll hit escape and then do my :WQ to be able to write and quit the changes. And it's like, yeah, it looks like the changes happened. All right, let's cat out that file. We could cat out James /example1 and be like, yep, Bob was here. All right, so looks like the information is now to the point where we could read the permissions, we could see that the file is now writable by other users, and catting things out kind of confirms all this for us. So understanding permissions is definitely really, really critical to maintaining certainly security on a computer, especially when you have a multi-user system, which is really what our servers are. Servers oftentimes have multiple users on them. Let's see what happens if Bob tried doing some of this stuff. So what happens if Bob tries changing the permissions to the example2 file? So right now, Bob only has permissions to be able to write to the example1. What happens if Bob tries changing the permissions to example2? Let's give it a try. So not as the sandbox user this time. This time as Bob. I'm going to do a chmod, and we're going to try changing permissions. How about we'll give like full permissions? I'll try doing a chmod of 777 to something like the James /example2 file. What's going to happen? And it's going to say, you're changing permissions of something that, you don't actually own this. Operation not permitted. All right. So when you're doing this, you got to have to understand, like, do you have ownership that allows you to actually change the permissions? And for most cases, it's like if you're not logged in as the person who owns it, you're not actually going to be able to do that. Now, it is kind of a nice idea. You might be sitting in the back of your head going, yeah, Bob's not the owner. But, what was that magic word to get what we want, right? When you're looking to try to run commands, and if it doesn't work right away, if it tells you don't have permission to do it, a lot of times the knee-jerk reaction is, well, let's try sudo. All right, so you could try running this same command as sudo. So how about as Bob, we try running sudo chmod 777 of James /example2. And when you try that, it says, all right, well, first you got to confirm your password, prove you actually are Bob still. No one has sat down at your computer and is messing with you. It's like, yeah, I'll type in my silly password again. And it tells you Bob is not in the sudoers file. Not in the sudo. This incident will be reported. Whoops. Okay. So apparently Bob does not have permission to run things as sudo. All right, which in many ways is a good thing. It's a good thing to realize that when you create a brand new user, that brand new user doesn't have full access to go running whatever the heck they want on your computer. So our sandbox user did have the authority to invoke sudo, but our brand new user, Bob, they did not. They did not have the authority to be able to do that. Anyway, so I'm not saying that there's a right or wrong. We'll explore the sudoers file in just a minute, but realize, yeah, this information does get stored to a log file, and there's the sudoer file. The sudoers file is going to be important for us to understand what is sudo all about, and we'll go take a look at that in just a moment. A few more things you might want to try with permissions might be, well, what happens when I want to restrict permissions? Right, we just saw what it was like to give higher level permissions. What if I wanted to restrict permissions? Maybe I'll restrict permissions to the James folder. How about I make it so that only the owner, only the James user, they're the only ones who can actually see what's inside this folder. So instead of giving everyone permissions, I want to kind of restrict everything down and lock it down so that only I'm the one who can actually see what's inside of that. All right, let's give that a try. So we could do a chmod, but this time instead of saying 777, maybe I'll give myself full permissions, and the group will have 0 permissions, and everyone else will have no permissions. So chmod 700. It's kind of a way you can give your own user account full permissions and give everyone else nada, no permissions. And now you just need to type out the file path of what's the thing you want to apply this to. It's like, well, I want to apply this to home/desktop/James. That's the folder I'm trying to apply this to. Sure, let's give it a try. And now when I do my ls-l, it's like, yep, now you'll just see here's my James folder, and there's a whole bunch of dashes. So it's like, I have permission, everyone else, yeah, no permissions for anyone else. So if you're the Bob user, what happens when you try to look inside the James folder now? What if you try LSing it? What if I try doing something like ls of /home/sandbox/desktop/James? And it says, yeah, you can't even look inside it. Okay, and realize Bob even has a file that's in there. Bob owns one of the files in the directory, but Bob does not have permission to get a list of everything that's inside the directory. He can't read the directory itself. So you can have things that are owned by you inside a folder, but that doesn't mean that you can just say, hey, Linux, show me the entire folder and everything that's inside it. Linux says, no, you don't have permission to do that. You have permission maybe to one thing inside there, but you do not have permission to everything inside, to see everything inside the folder. So what happens if Bob tries LSing out just his file, right? If I try doing just that one, if I try doing an ls of /home/sandbox/desktop/James/Bob's file, right? You'll see again, it's like, oh boy, yep. When you want to try to access that, again, the permissions have now been restricted because you don't have the ability to read what's inside that directory, even though that you have a file that's inside there. Oh, what if you try catting it out? What if you try catting out? Like, has this file been completely removed from my access? Let's try catting it, right? So if I try doing a cat of /home/sandbox/desktop/James/Bob's file, right? And again, it says, nope, you've been locked out of this. All right. So this is something we have to be critical in understanding, that folder permissions are really important as soon as you start dealing with multiple users. What are the things you actually have access to? And understanding that our Bob user, they're just kind of a lowly user. They don't have the ability to invoke sudo, so they're not going to be able to overcome this. All right. So let's go and try something else here as the sandbox user. So right now as the sandbox user, if we look inside the James folder, we of course can do this because this is ours, and we can confirm the permissions, right? I'll do an ls-l as the sandbox user inside the James folder, and we can see like, hey, there's this Bob folder inside of here. Right, this Bob folder is currently inside. Can the sandbox user make changes to the Bob file, to Bob's file? Can the sandbox user actually go and make changes to this? It's like, well, it says read, and maybe not. Let's try it. Let's try it. Let's see what happens as the sandbox, because sandbox has kind of started to lock down this folder. They're the only ones who can look inside it. It's like, well, what happens if we try nanoing into Bob's file? I'll nano into James/Bob's file. Okay, and what does it tell? It's like, well, nope, unwritable. All right, so even though we're the ones who kind of lock down this folder, that doesn't mean that we have full permission to everything inside of it, all right? And so even Bob's file doesn't currently belong to us. And of course, if the sandbox user tried changing the permissions to Bob's file, what's going to happen with that, right? We could do a chmod, maybe we'll do just like before, a 666 of James/Bob's file. And again, you'll see it gives you a warning. It says, nope, you're not the owner. If you're not the owner of the file, you're not going to be able to change permissions to the file. Unless, of course, you can use the magic sudo word. Right? Sudo is the magic word to get us what we want. So even though the sandbox user doesn't have the authority to change permissions on the file, the sandbox user does have the authority to invoke sudo. And so if we run that same command, but this time we add on a sudo to the front, right? Sudo chmod 666 of James/Bob's file, right? Now we'll see it's like, yeah, go ahead and confirm you still are the sandbox user. We type in the password and it didn't give us an error that time. All right, let's hit a couple up arrows and run our ls-l again. And we'll be able to see it's like, yeah, this still belongs to Bob. However, because we could invoke that root level privilege, that allowed us to run a command that our normal user account would not be able to, not have the authority to actually run. So it becomes really critical to see who is actually capable of running sudo and who is not capable of running sudo, okay? Because now we kind of just gave ourselves the ability to write to this file. Let's give it a try. Maybe we'll try echoing out a message inside it. I'll do an echo of ha ha ha, and we'll send that into the file. We'll send that into Bob's file, right? We'll append this on into the file. We won't overwrite it. And we'll send that to, where is it? home/desktop/James/Bob's file. It's like, yeah, sure, we just sent the message there. Let's go ahead and check the permissions now. And we see it's like, well, the command seemed to work, right? I was able to send permissions in there because everyone now has write permissions. And if I try catting it out, the James/Bob's file, it's like, yeah, ha ha ha. Yeah, so even when you have a file locked down, if I'm able to act as the root user, I probably can start overcoming the built-in ownership and permission requirements, because the root user, of course, acting like the administrator, will be able to have the authority to do those types of things.